Good evening, everyone. Am I audible? Okay, that's good. So till now, I think so. Is it clear with the intermediate labs? I think you have finished all the intermediate labs, right? So today I'm gonna discuss with the advanced level. So we'll understand the two things. One is what is generative AI, okay? What are the different models we have? What are the transformers? What is vertex AI, okay? And also show that how to finish the remaining advanced level labs, okay? So in this, we will learn complete about generative AI. So how this generally generative AI generate the image. So and how it is going to generate the text. All these things we'll get to know. And in that, we will know about image. So how this deep learning works. Okay, all these things we'll discuss. So if you have any query, just post it in a chat. So we'll discuss. Screen once. Guys, are you able to see the screen? Is it visible? So now we are in advanced level. Okay, till now we discussed about beginner and intermediate. Now in this session we'll cover these topics. So introduction to image generation. Okay, so some models will generate images from text. So you hear right. So today we'll discuss how this will generate and all this is going to happen. And next we'll discuss attention mechanism. So it is a very important topic about attention mechanism. What this attention mechanism in general will do. After that, encoder decoder. It is also one of the important models. Transformers. So it will help you to do text based things and discuss. create image caption model. So how this caption will generate? So if you give an image, it will generate caption. So I'll discuss that too. And also introduction to vertex AI. Along with that, we'll see the vector search and embedding. So this will help you to do convert the normal text into vectors in a number format. So because the machine will not understand general text, right? So that is the thing, we convert the numbers into text. So text into numbers. And coming to responsible AI, we'll discuss that too. I think you have seen in the first beginner level. So this is in the last advanced level. After that, MLOps, machine learning operations, we'll discuss that too. And responsibly, all these things we'll discuss in this session, guys. Okay. So before moving, I'm going to share the things. We'll discuss first what is generative AI and how this image will generate. Okay, that part. Sure. You'll get the credits, guys. Don't worry. I'll just inform to the team so that they said that the Google will send you the access. Okay, they'll give the access. Just wait for a minute. I will inform you. Okay. Yeah, already shared. No, just what I shared the link first link IBM. Just finish that one. Okay, it's fine. That IBM will share. No, finish that course. It's guys. Are you able to see the screen? Is it visible? Not just let me know. So till now, what we discussed, just beginner level as advanced introduction to generative AI, right? So we discussed different models. What is different type of models we are going to have, and we discussed about discriminative and generative. That we'll discuss in detail in this session. And also we discussed about beginner level labs, all these things stuff, and as well as we discuss intermediate. Now in this continuation session, we'll discuss about some of the generative models. So I already said that we discussed about machine learning, right? So in that we're going to have data which is in a supervised and unsupervised data. So we have different models for that data, right? Now machine learning going to have some models which we call as a predictive models. Okay, generally to do some tasks. For example, I give you a general example. Consider there is a house rent. Okay, you want to predict house rent. or else selling price. Okay. So what things you're going to collect? For example, you build your own model. That model need to say, if you give some instruction, this is a house area, square feet, okay, have 2 bedrooms and kitchen hall, and it is near to road, and it is in the city. So these are the features. Based on the features, what you're going to do, your model going to need to do, it need to predict price. Okay. So these are the features generally we're going to consider to predict a house price or a rent. Okay. These are the features we're going to predict the house price or rent. So using some models, we can predict the house price. So prediction is nothing but what are the data we are going to give for the model. For example, this is a 200 square feet of building. In that you have 2 bedrooms and 1 kitchen and 1 hall with the attached balcony, and you have some facilities. It is near to main road as well as it is in the city. Okay, there is apartment or else building is in the main city. So the cost of the rent is nearly 30,000. The cost of the apartment was 30 to 60,000. Okay, this is a data. Like this, I have n number of data, like n number of rows I have. Okay, with the different features. Some are in city, some are on outskirts of the city, as well as some are double bedrooms, some are single bedrooms, and they are adjusted in small, little bit small area. So these are consideration of these things. The price may be vary, right? So using this data, I'm going to train to my model. I'll train my machine learning model. So what this machine learning will do, it will predict the new data points. If you give new data points similar to like this is my house, so I want to know what is the average area, means rent of this apartment means, then it is going to give this is the average rent you need to pay for that apartment. It is going to suggest, right? So when the model is trained and huge amount, then it is going to predict, means it is going to give whatever we are expecting, right? So we are expecting the price, so it's going to give the price. Or else, for example, I give an example of cat and dog. So in coming to the deep learning, we are going to train with the cat images, like cat is running, cat is sitting, cat is walking, as well as we train with the dog images, dog is running, sitting, walking. All the things will train with the different types of images. Model will learn some features, and finally it will predict. If you give a new image, for example, you give the cat image, it will predict is a cat. If you give the dog image, it will predict it as a dog, right? So here the main point you need to understand that the model which you train, and you will expect the y is nothing but labeled data. Okay, if that predicts, then we say it as a predictive model. Okay, predictive model. We say it as a discriminative AI. Okay, we'll discuss clearly. Okay, if you get confused, okay, so you'd be a little bit confused if you're hearing the first time. Okay, so as well as machine learning have some models which is going to predict. Okay, now we are discussing in that way house price or cat or dog is going to be predicted. So we say it as a discriminative predictive. So machine learning, deep learning will do this task. Okay, and how the machine learning and deep learning have some models to do specific tasks. In the same has generative AI as some models. Okay, so what this generative AI models will generally do means is the same previous, it not going to predict. Okay, it's going to generate the new data. Yes, it will generate the new data based on the trained information. So it also going to be trained, but it not going to predict what you are expecting. Okay, is this a model is a correct model or no? No, it's not going to give that prediction. It will give the complete information about that question or on whatever you are expecting, that it is going to generate new thing. So that is the thing we call it as a generative models. That is the thing we call it as a generative AI. Okay, is it clear difference between machine learning and deep learning as a generative AI? Why we call it as a generative AI? Okay, it is nothing but artificial intelligence. That is a part of generative. Gen AI is a part of artificial intelligence. In this, we will go somewhat deeper, understand the generative AI core models. Okay, and we'll discuss about LangChain. That is a framework will help you to do work friendly manner. It will help you to do create a number of models. It will help. Okay, so that is a LangChain. Now, so what we discussed till now, that is going to be repeated. Just generative models is a branch of machine learning focused on learning underlying probability distribution of a data set, allowing the model to generate new samples that resemble the original data. So see here. So they have said, gave an example. So you train the model and different images using different images. See, you can sometimes the cat is sitting, does, so it is doing some different expressions, right? So what this is a complete training data. We train the generative model and also we give some random noise. Random noise is nothing but the data which is not going to have any structure or pattern. Okay, that random noise will input to the model. Model will observe the patterns and this random noise is going to convert into a beautiful image, new generated image. Using this random noise, it will generate a new image. So this is a thing what it will do means it will learn some features from the images and it will underline the probability distribution, nothing but it will understand the how the data has been dispersed in these images and that information is applied on the random noise. Then using that random noise, it will generate a new image. So this is the thing is going to happen in a generative model. Okay. Use cases where we use generally these generative models. Generation. So have you ever wondered how these models? So you have ever seen some ladies, okay, sorry, some images like a newborn kid. If you take the picture of that boy and if you apply some filters, that will convert that image after 60 years, how this boy is going to look like, right? It has recently it became more popular. So if you give image after 60 years, how you're going to look like, it gives image, right? So how the model will know that he's going to be look like after 60 years, right? So these all things was done. It is going to be work done using some models that we call it as a generative models. Okay. Text generation, writing articles, poems. You have already seen that there is a lot of text models, Gemini, IBM. Next, we have ChatGPT mainly, which is became more popular, right? So, which is going to give the complete information about text, right? Audio synthesis, generate the music and speech. Okay. So nowadays, a lot of people are using this generating synthesis, audio synthesis. Means see what they are doing. Who is people are not alive, okay, who is passed away. So using their voice, AI generating the vocals means how they singing in the past using the data, they are getting that singer's tone back into the music field. So that is possible with the generative AI. Data augmentation. These are a very important thing. Data augmentation. Okay. What this data augmentation will generally do means data augmentation what generally it will do means, for example, if you have huge much data, okay, but you need to predict fake data and good not fake data. So I'll give an example. Okay, we'll discuss this in the data augmentation. Okay, let me just move on. And data augmentation, nothing but it is going to generate the synthetic data, which is going to look like same as original data. So that will help in some scenarios. Okay, what is that scenarios we'll discuss. Anomaly detection, identifying the unusual patterns by measuring how out of the place. Means see, sometimes in the areas we're going to get earthquakes, right? So in that scenarios, based on that patterns, it will observe. So daily, what we'll do, they'll feed the machine of this is the data about right now the temperature, all the things, weather, all the things they will update, and it will also learn what is the data when the earthquake occurred. So that data also is going to be trained. So if that scenarios matches, then it is going to give an alert that so here you are going to get majority of earthquakes. Please be get ready. So in that way, it is going to suggest. So then it is going to be right. That now coming to the GANs. So this is the main play the key role in image generation. So how the models nowadays, you can see that it is generating images from text to images, right? Generating from this model, generating it from text to image. How the model will understand what we give. For example, we say that red light, green light. Let's say if we say that red light, green light. Okay. How the model will understand this is a red light, this is a green light. Means it will convert the text into numbers. That numbers will understand by the model and it will do. How this going to work in the background means we'll see. GANs is nothing but generative adversarial network. So I'll explain what is generative means. It will try to generate new thing. It will try to generate the new thing in generate adversarial. So what is adversarial means? Adversarial means these adversarial generally what it will do means it will conflicts every time. Means what this conflicts means sometimes who is arguing with you, right? Every time they conflict, right? So when you say anything, just they will start arguing with you, right? So these adversarial it will do. So why this term came into this means we'll discuss in the architecture. Network, so you know that it is a building of these two things, generator and adversarial networks. We combine this, we'll make an architecture. So this GAN is going to work on these things. So we'll discuss in architecture, we have two things. One is generator, another one is a discriminator. Okay. What is generator? What is discriminator? Generator, the name is suggesting that it is going to generate something, right? It's going to generate something. Discriminator. First, we'll discuss about discriminator. See, I'll give an example. For example, there is a thief. Okay, there is a thief who is going to try to is trying to theft something from a house. Okay, so for that, what he is doing, he started some fake generation. Means see, so if we want to theft something from a house, he need to replace some duplicate items there. So then no one will catch him, right? So he thought in that way. Okay, the thief want to theft some means he is trying to theft them something from the house. So like it is a thing. Okay, so he want to replace that thing. So what he will do? He will try to get some fake item. Okay, that fake item, and he'll theft something and keep it. He is going to replace with the fake item, means duplicate item. Okay, and after when it is coming to detective part, so what these detectors will do, they'll start investigating and complete things and try to get that item is fake or original. So he's going to catch the thief and he will compare both which one is good and which one is fake, right? He will check and he will replace original one and he will say that this one is fake. Okay, you're clear with the story, guys? That's good. I think you're clear with the story, right? So what thief will try to theft something from home, and what he will do, he'll just replace the fake duplicate item, and he'll just take out the original, and he left the house. So when the detective came into the place and just he started observing, when he catches the thief, and he will just observe things, which one is fake and which one is good, and just original item, he will replace that. Okay, and he'll say this is a fake. So here the same story is going to happen. This discriminator act as like a detective. Discriminator act as like a detective. What it will do means it is going to train on a huge real images. It is has been trained on a huge real images, and this generator act like a thief. This generator act like thief when he had noisy data. Noisy data means there is no structure, right? That data is passed to the generator. Generator will understand some patterns and just generate a fake image. It will generate a fake image. Okay. This fake image is going to send to the discriminator. This fake image which has been generated by generator. So send to the discriminator. Discriminator will observe the two things. One is which one is real and which one is fake. So it's going to analyze and going to say this one is fake, and that information is passed to the generator. And again, generator start updating the items things, and it will generate one more image. In this way, every time the generator tries to make a fool this discriminator. When the discriminator is going to be fooled? When the discriminator is going to be fooled means when generator generate accurate image, that discriminator can't find which one is real and which one is fake. At that time, the discriminator is going to be become a fool. So that is the adversarial. They say that the conflict is going to happen between discriminator and generator. So this is the thing they finally this generator generate a new image, and that is passed from discriminator, and it is approved this is a real image. So this is the thing is going to happen in GANs. Okay, is it clear how the GANs network architecture is going to work? Generator will take the noisy image, means noisy data, randomly assigned values, and it is passed to the generator. Start generating images, and in the meanwhile, the discriminator start learning from the real images. And when the generator is passed the fake image, it will classify and say that which one is fake and which one is real. Is it clear, guys? That's good. See you next. Okay, you said, sir, that a generator going to generator. Then how the generator will understand how to it is going to know. For example, if we say to newborn kid to we going to train a number of images, then if we show a new image, he can find, right? By if you train with there is a newborn kid. If you train like daily, you will show that this is a cat, this is a dog, this is a cat, this is a dog. After a few days, if you show a real dog, he can find that which one is dog and which one is cat, right? So then how generator will understand from noisy data? Noisy data means there is nothing patterns is there. Then generator going to have different layers, guys. So from deep learning, what this deep learning will do, it will mimic the human brain. Mimic the human brain means how the general neurons we have and how we can sense the things. In the same way, this generator going to have some convolution layers which has been taken from CNN in deep learning. Convolution layers is nothing but it is especially designed for to capture some patterns from images. These neurons are specially designed to capture some information from the images. So here generator will use that type of layers in the background and use some dense layer. Dense layer is nothing but convert the single array, means single value, single column single column image into 2 into 2 pixel, 3 into 3 or 64 into 64 or 32 into 32 size of pixel, convert that into image format, and it will try to generate new image. So it will pass random noise vector Z, we call it as a Z. From that Z will get the output as generated image. Okay, so we got, for example, you send the 100-dimensional image, then it will convert that into a very structured format of image. Okay, so this is the thing is going to happen in generator. What this generator will do means it will take the random noise of 100 values, consider from 0 to 1 lakh you have some values. Okay, in that it will collect the random values. Okay, it will collect the random values in a single row. Okay, single column. So that values is passed to the generator. Generator what will do? It will structure first. It will make it as into 2 into 2, 4 into 4, 8 into 8, 16 into 62, 32 into 32, 64 into 64, size of height and length of the image, and it will make it as a image shape. For example, generator we are training 28 into 28 image size. Then generate a discriminator. We are training the discriminator with the 28 into 28 size of image. Then generator will finally generate the same size, because we need to specify the image size. Based on that, generator will generate that size of image as a fake image. Okay, it will take the 100 values, dimension values, and make it as into output size of expected size of image, and it will try to generate a fake image. So as I said that it's going to have some common layers. Layers is nothing but neurons. Inside that model, we are going to have some neurons. Okay, that neurons is going to perform this task. So each each layer has named as different layer names that fully connected as a dense layer. Fully connected means every neuron is going to connected with the value. Every neuron is going to connected with the one value. So then we say it as a fully connected layers. Okay, often used to initial project and reshape the size. So they start reshaping this. Z is considered as a noisy data. Okay, reshape and transpose convolution layer or deconvolution layer. So they will use convolution layers and mechanism to partial and upsampling the image generation. Means it will start upsampling, means it will add layer by layer, means image 2 into 2 converted into 4 into 4, 4 into 4 converted into 8 into 8, 16 into 62, 32, 32, 40, 64, 64. Like that, it will go on upsampling. Then it will try to generate that image. Okay, it will use kernels. So what these kernels generally will do means it act as like a filters. Okay, guys, filters is nothing but it will get some random noise that will apply on that image, and it will extract the important features. So in that way, the filters will help to model to learn and generate the image. Batch normalization means generally what it will do, if it is huge values, it will take time to computate the data, means like calculate the data, it will take time. So what this batch normalization will do, it will adjust the scaling, means if the value was between 0 to 255, it will adjust that 0 to 10. All values in that row, it should be in the 0 to 10. So now it is easy to calculate, right? Before it was 0 to 255, it is quite difficult to calculate. If it is in 0 to 9, then it is easy to calculate. So in that way, it will scale that. So that is the reason we use normalization. We have activation function. So what this activation function will do, it will give some complexity. For example, the model learned easy way. So okay, this is a number. Next, I need to get other number. So in that way, it will understand the pattern. It's not going to observe the complexity. It will understand only pattern. So to avoid that, they introduce this ReLU. ReLU is nothing but it is one of the activation function. Total, we have a number of activation functions, like 75 activation functions. In that, we are using a ReLU for hidden layers. What are these hidden layers? Hidden layers is nothing but which is going to have inside to do some calculations. They're going to have some hidden layers. These hidden layers will act as to generate to do specific tasks. These hidden layers are going to be main layers. Okay. So using some different activation functions, they will learn complexity in the neural network. Okay. So we have different types of GANs, means for do specific purpose, they introduce specific GAN. So DC GAN is nothing but deep convolution GAN. Okay. MNIST is nothing but some one of the university which has been prepared this data set. So that is the name as MNIST. MNIST is nothing but they have data with what type of data do you know? MNIST. Have you ever heard this word MNIST? Anyone? So what is mean by MNIST data set? What is the data set contain? Do you know? Anyone? Yes or no? MNIST data set is nothing but data which is going to have your handwritten digits. Means, see, for example, one person, there is a person one who will write in the format of some cursive writing. So he'll write, he is going to have different format of writing 0 to 9 numbers. He will write in a computer, how the computer will, how this machine will write. In that format, one person will write. Some will write in other format. So every person is going to have different handwritten digits, right? If you ask to your friend, he will write 0 to 9 in a different format. So you will write in a different format, right? So design is quite different compared to your friends. In that way, this one university has collected huge amount of data set, like nearly 70 to 80,000 of images of a handwritten digits, 0 to 9 handwritten digits. So that we call it as a minis data set. So using that minis data set, we are using some random noise, means 100 values we are using. And we use first layer as a dense layer, and that is reshaped to 7 into 7 image size. Okay, like that we'll add layers. Next we added convolution transpo layer, and it is converted to 128, means 5 into 5, 128 filters applied, and next 64 filters they applied. Final they going to give the output as 28 into 25. Why? Means the image size in the minist was 28 into 28. So generator need to generate into 28 into 28. Or else if you generate in other way, like 34 into 35, then definitely say it has mismatched, right? So that is the reason we need to give the last layer as what is the output of dense discriminator image size. In that way, you need to specify. Yeah, I already said discriminator, what it will do, it will get the fake data, means it is going to train on real data. P data is nothing but real data, so it's going to have fake sample. Generator will give the fake sample, and it will observe the probability real and fake, and it will give some output. So if it is that high, then it will say it is a fake data. If it is too low, then it is say as a real data, and it will exit. Same as how the generator had the layers, in that way same discriminator had some layers. Same, it need to analyze the image, no? So they use convolution layer, and see here they use some activation function layer, and again they use batch normalization. Dropout is nothing but, guys, so sometimes the model will learn more complexly, means it will observe each and every pattern, then the model will not perform well. So to overcome, we'll drop some of the neurons in the background. Okay. So that is the thing, we use this regularization and preventing overfitting. Okay. Next, flatten layer. Finally, it will convert that layer, and it will understand the features, and it will start analyzing which one it is matching to the same features or not. So in that way, discriminator learn and give the output. Okay. Simple DC GAN. So for the minis dataset, these are the layers they're going to use. First layer is input. Second is convert 2D convolution layer as a two-dimensional, and final output they will make it as a sigmoid. Sigmoid is nothing but is in one of the activation function, as we call it as a linear regression also. Sorry, logistic regression we call it as, and it is going to give the yes or no answers, right? 0 or 1, yes or no, like this it is going to give. That is the thing we use as a sigmoid activation function. So these are the training algorithms, how they generally it is going to train in them. Okay. So some of the challenges while just training the generator, means GANs. So mode collapse, vanishing gradient, and oscillation. So mode collapse is nothing but when discriminator will learn huge heavy. For example, you trained on minis dataset. Okay, your model you trained on minis dataset. In that, discriminator has been trained with the minis dataset. It has been trained each and every part, like black dot, white dot, and fingertips. Means like every each and pixel it has learned. So when the generator generating the fake image, it is not it has been mismatching every time. Why? Model discriminator has been trained on each and every part of the image, no? So when you this new image generated by generator, it is not accepting because it has huge information. So if this happens, then generator is not going to generate 100% accurate image, right? So it may get 99.9, but discriminator has been trained on 100%. So this thing is never is going to happen, right? Discriminator never accept which one is real and which one is fake. It's not going to happen. Every time it will say this is a fake, 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 fake. So this thing happen, it is going to be become a infinity loop. So then the mode collapse is going to be happen. So this is the issue in the discriminator. And one of the main problem in predictive models or generative models is that vanishing gradient. Vanishing gradient is nothing but while neurons is there, no, we already said that is a human brain mimic. Hence it's look like human brain. Okay, so these neurons, what it will do, while it is going to have the concept of weights concept. Weights is nothing but some random numbers is going to add it to get some complications. Okay, means to learn model complexly, they add some weights. So these weights will play the crucial role in a uh, neural network. So while n number of times this generator is going to be trained, so sometimes the weights will be neglected. Weights will become zero. If the weights will see, for example, if you multiply any value with a zero, you'll get zero. So when this weights will become zero, if they multiply with any of the number, the neuron will deactivate it because the value completely becomes zero. Then the neuron is going to be deactivated. So the model also failed to give the accurate results in that scenario. Oscillation, so already said the oscillation that it's going to rotate n number of times. So it failed that in scenarios. So you'll get the issue with the oscillation. So these are the issues with the while training model. We need to take care to get a best results. Next, variational autoencoders is another model we'll discuss in the upcoming session. Okay, is it clear with the GANs? So there is, do you know, n number of architectures we have on GANs, means models for everything, for styling your image, for when you apply some filters to your image, you know, for that background they have style GAN, or else some GANs we have DC GAN, W GAN. So like that, they introduce total 28 GANs architectures. So that is a big one. To do specific task, we'll use specified GAN. Okay. This is about the story of generative, one of the generative model, that is a GAN. So I think you cleared with the how this image is going to generate. We'll see some codes, okay, lab using what is the generator. 2 minutes break, we'll continue. Okay. Okay, guys. So that is the thing about these GANs. So do you have any queries about this? If not, just I'll go to the next lab. We'll see that how this image generation, all these things we'll see in the labs. Okay. Introduction to generating image. Okay. We don't have any lab in this. So yeah, from Vertex AI you have that. So I'll discuss one more topic in continuation of Vertex AI. So tomorrow we'll discuss about this Vertex AI, and next we'll see the vector search embeddings. Okay, and these things we need to finish all these labs, guys. So we'll discuss about responsible AI developers. Okay, fairness bias, all these things, and see the machine learning operations. 5 hours means responsible privacy and safety. You have one lab, so you have 2 labs on safety and security. Try to finish that. Okay, then we'll discuss these topics too. Okay, so what is attention mechanism, encoder and decoder? Okay. Just let me share my screen then. Guys, are you able to see the screen? Is it visible? Just a minute. Now, are you able to see the screen? Not just let me know. I'll check it once again. Okay. Yeah. So we'll discuss one more topic, that is encoder and decoder. So before moving to one more generative model, just I'm gonna give this overview about this encoder decoder. Okay. So what is encoder and decoder? So this is a part of deep learning where it will deal with the unsupervised data. So what is mean by unsupervised data, guys? What is mean by unsupervised data? Anyone? What is mean by unsupervised data? Okay, let me. Yeah, that's correct. So the data which is not going to have any structure or format, right? So for example, there is a huge people who is entering to the college, like I'll say it as in a. So they are like a new admission. Consider that a new admission who has entered into the new to the college. So we need to what we need to do. Just we need to separate our data, right? So who is the part of BTech curriculum? They're going to separate as a branch of BTech. Who is a part of other branches like MBA or else like masters? So MTech. So they're going to separate, and sciences they're going to separate based. So here what we are doing. So this generally unsupervised data is going to be form a different classification. So here in our data, like new admission students who enter into the college, they're going to classify it into based on their performance. Means based on the relative who has a subject of mathematics, they're going to send to science branches. Okay, who has the different like finished the undergraduate, they're going to send as a post graduation courses like MBA, masters, MSc, MTechs, right? So these are the post graduate course they're going. So here we are going to classify based on their results, previous results. It may be a undergraduate, it may be a postgraduate. Based on the previous data points, they're going to be segregated according to their classification is going to be done. We call it as a generally as a clusters. Okay, we are going to form them in a different clusters and make it as a group. So one group. So how we say that group means generally cluster is nothing but completely BTech branches. Complete BTech is going to come under a cluster. In that, we are going to have separate groups. What type of groups? Like it is maybe a CSE group or electronics, civils, mechanical. So we're going to have different branches. So that is going to call it as a groups. Okay. So that is the difference between cluster and group, guys. Okay. Now, so these encoders generally deal with this type of data. Okay. These encoder generally will deal this type of data. Encoder, decoder. The name is suggesting that encoder will do some operation and that will do decoder will decode that operation. Like how it is going to look like. Encoder means something it is going to cover the entire part. Decoder what will do? It will open that cover, right? So we can assume in that way the name is suggesting. We'll see in somewhat deeper. So encoder going to have one encoder part. It will take the input data first. Okay. Okay. Like saying how we enter into the class college first. It will take that encoder will take that part. And next, it may be image or it may be sequence of text. Okay, continuous data will say. Or else we'll say it as a text sequence or time series data. Okay, so it will fixed length vector representative known as Latin space. So what it will do, for example, we'll consider the previous example as an image. Okay, we can do with this encoder, we can do image, we can process the image as well as text also. Okay, for my understanding purpose, I'm going to consider as an image. Okay, now this encoder, what it will do, it will going to use some convolution layers. Same here also, the same concept is using convolution layers. So if it is text data, it will use recurrent layers. Okay, don't get confused. So there are the different layers. Convolution layer, which will deal with the CNN model in a convolution neural network model. These mainly designed for image processing, like complex data is image processing, so they're designed. And for text data, they designed other neural networks like RNN, LSTM, GRU. Okay, so now we are taking the example of CNN convolution layer. This will help the model to extract the important features from the images. Okay, guys, it will help the model. What it will do, it will help the model to understand information, means it will extract the main part of information from that image, and that information is going to convert into Latin space. Latin space is nothing but which is going to carry the complete information. For example, consider this slide as image. Okay, you are passing to the model, this is a complete slide you are passing to the model. Okay, guys, is that clear? Now what the model will understand from this image, it will capture this smart intense logo, right? It will capture this heading and subheadings and the text. So it will capture this information. Remaining, what are the part we have in this image, it is going to be neglected. So this image, the white space and the background image is being neglected, or else the background image is going to consider some of the information is neglected. So this information we is going to formed convert into numbers. So that numbers is going to carry by this Latin space. This will store it is in a complete format like single vector. Okay. Next, from that Latin space, this decoder will start decoding. Okay. I'll give general example. What is the thing? For example, guys, see here. See here. This is the best example for encoding decoding. So this is my image. Okay. This is my image here. So if I ask you to analyze this image and please let me know what are the objects you are detecting this image in this image. You get to know what is the thing. Just let me know, guys, in the comment. What are the things you are observing in this image? Objects in the image. Anyone just let me know what are the objects you're able to see in the image. Are you able to see the screen? Is it visible? Yeah. Yes. So see here. See here. So in this image, the first image, the dog is sitting and the three persons in the background of the dog and the sofa set. They sat on the sofa set. Okay, this is the thing you are observing. So if I give that image in a puzzle format, so what you will do, you will just start adding one image, one puzzle by one puzzle. Means you are trying to match each and every pixel of that image, right? So consider these images where we are generally passing to the model. Just we are passing, just we are sending this image to the model. Model what will do, it will get the all the information like background, you can see that some boards, photos you can see, and the three persons sitting, all these things, napkin, you can see all the information captured by the model. Okay, that information passed to the decoder, and decoder will start reconstructing the image. Decoder will start reconstructing the image. For example, if I give only, don't see this image, and if I give this image to a particular student, if I give an image to this particular student and ask you that, so what are the objects you can find in this image? So the student will observe and will say, okay, the dog is sitting and the three persons are behind the dog, and on the sofa set they sat, and there are some frames, right? So if I tear this image into multiple pieces, and if I ask that boy to reconstruct this image, please reconstruct the image. So then what he'll start by attaching each and every piece, like he's checking that there is some door and it need to match with that door, this image, and after that the frames need to match. All these things he'll check each and every image, and they start matching and make it as a complete picture, right? So in that format, this generally the encoder, what it will do, it will tear each and every feature. It will extract each and every feature and make it as a Latin space. From the Latin space, it will start reconstructing the image. So this is the thing is going to happen in encoder and decoder. As same as in the text also. See, guys, in the previous I said, no, there's a minis data set. This is a minis data set. So it's going to look like this. So some 0, 7, 9, 8. These are the numbers captured in a images that has been stored in a minis data set. So we'll pass that to encoder. Okay, we'll pass this complete data set to encoder. Encoder will extract the features and convert into single vector is a Latin space. That Latin space, from that Latin space, the decoder will start reconstructing the image. Okay, this is the thing is going to happen. Whereas in encoder decoder, if we go with image, means text, or in the text, it will start doing some embeddings. Embeddings is nothing but which will convert the text into numbers, numericals. So encoder will convert and decoder will reconstruct that text into same format. Okay, so this is how. For example, there is a sentence, king, queen, eating. So this is my sentence. So it will start analyzing the each word and make it as a one vector. This is how it is going to look like. Means see, for example, there is a sentence which is going to have some words. It will extract the unique words from the sentence, and it will check that each sentence has same words or not. Like this is going to form a vector. Okay, this information is called as Latin space, that is passed to the decoder. Decoder trying to construct these words again. Okay, is a thing clear, guys? In decoder, you're going to have different layers. Input layer. Input layer is nothing but data we are passing. That is the thing we call it as input layer. And coming to processing layer, if you are processing with the convolution layer, you're going to have the convolution layers. If you are processing with the text data, you're going to have sequence layers, that is RN and RNST. Okay. Feature map means that you're going to, after processing that, you're going to convert that into a format, text format, means like a vector format. In decoder, you're going to have embedded layers, means the text data which has been came from the Latin space. So that data is passed to same convolution layer or recurrent layers, and that data is converted into real data, means that image or thing is converted into real image. And next, as using some LSTM layer, conversion layer, and it is going to give an output as real image. So this is the C. You can see here. For example, if you feed this image, final output, it will convert that image into in this size. So this much big image is going to convert into, it will make it as a small image. After that, it is going to make as a single vector, that vector, and it start reconstructing again in the same size of that image. You can see here. RGB image is converted to segmentation of this image, right? In this way, this encoder decoder going to work. So different Latin vector output generation, unsampling, transpose, convolution. So Latin vector is going to be used to unsample that into using some upsampling. Means same in the generator, how generator will convert the single vector into image. In this way, the single vector is converted into, again, it will do upsampling. Upsampling is nothing but convert the image into the data into a perfect image. Okay, these are the layers. Fully connected. Fully connected means, what is fully connected? Every image, every pixel is connected to neuron in a single vector. Okay, using that, this to use transpose layer or convolution layer, and this or else if it is text data, they use LSTM. Okay. So there are how they learn network means in a forward process and back propagation. Forward means this encoder will convert that into features. Features will convert into image. Decoder will do that. So in the back propagation, they will start from back propagation means a decoder will just do the process of converting that all the features into same Latin space. That Latin space is passed to the encoder. Encoder start constructing the image. So it will learn something while doing this process. So that is the thing they will do back propagation. Means they will go in a reverse process, like updating every way. Loss is optimization. Yes, the main thing is every model, in predictive model or generative model, the main task is to reduce the loss. Okay. So in where what are the scenarios where we're going to use this encoders means in like CNN based. Okay, we use convolution layers. Okay, transport image diagnosis and image compression. So when you are analyzing image, we use this encoder decoder like convolution layers. For image compression, sometimes we need to compress image, right? In that area also, we'll use this. In some text like mission translate, text summarization, also we'll use RNN layers and we'll use the encoder. This is a very, very important topic, guys, because these using this, there is a lot of models is going to work. Okay. Transformer based, so mainly used in the transformers. Okay, we'll discuss this transformers with the attention layer mechanism. Okay. Applications of encoder decoder architecture. Mission translate, so we have seen that. So we're going to translate from one language to another language. Text summarization, so some scenarios we are going to analyze the text. In that field also we'll use this encoder decoder. Speech to text, so voice is converted into text. In that areas we'll use this encoder decoder. So already discussed, there is a problem, that vanishing gradient, right? What this vanishing gradient will do, it will going to have the weights is going to be updated, so it will become 0, then the neurons will become 0 and the model will not give the appropriate results. We need to take that into consideration. Computational cost, while using the encoder, we'll need to train with a huge amount of data and servers. We need high computation, so we need big processing computings. So it will cost, it is not that thing, it is going to take huge cost. Long range dependence means this will carry the huge information, like uh, there is a 10 pages of article, so it will carry that complete information to model to perform some operations for next predicting next word. In that way we'll use long range dependencies. Issues will get that in this encoder. So this is a part of encoder decoder. Why we discuss this encoder decoder means this is one of the predictive model in deep learning. So these continuation, they introduce autoencoders and variational autoencoders, which will do the some generative task. This is a predictive model that will do generative task, and as well as this encoder decoder is used in transformers. So what is this transformer means? So you have seen now the models which is going to be like ChatGPT and Google Gemini, how they are generating text means using this transformers, they're gonna work. Okay, so that is the thing we discussed, this encoder decoder. Okay, is the thing clear, guys, with the encoder and decoder? Now we'll see that variational autoencoders and transformers. So here, I think you're clear with the encoder decoder, right, guys? So that in a generative AI, so they use variational autoencoders. This is the one of the model where they use to generate some text, okay, mainly used for text purpose. What is this variational encoders, autoencoders? We'll discuss. So the architecture consists of encoder as fx consider, decoder we call it as a g of z. Okay. Now encoders maps input data x to the lower dimensions Latin representation. Yes, that's true. Because see what this encoders will do. It will convert the information into Latin space, right? So what are the information you pass that will convert into Latin. Decoder reconstructs the input data as g of z from the Latin representation of z. So this z is going to be converted. This where is the information we get from the Latin space that converted into original data. So minimize the reconstruction error between input x and the output x tilde. Typically uses mean squared error. Okay, mean squared error generally we use in regression tasks, right? Or binary cross entropy to solve this to minimize the error. So why just what is mean by the error is nothing but bias, right? So these we try to reduce because, for example, we have original image, we have fake image. We need to get the loss between, means what is the difference between, how much is the difference between original image and fake image. That loss, that error we need to reduce in each and every model. Okay, for text data or table structured data. So what type of data it may be, you need to check that and try to reduce the error. Okay. Limitation for generation. Latin space Z is not explicitly regularized to the ensure continuity to meaningful structure for sampling new points. So there is some things issues with the Latin space to explicitly regularize means nothing but while generating data, means like decoding and generating new data, it need to go into based as the things happen main in the Latin space. Okay, it need to take care, otherwise it's going to cause an error and issue. Okay, and, these probabilistic encoder and decoder learn from probability distribution. Probability distribution nothing but the data, how the data has been distributed. It's going to check and it is going to give the information, okay, over the Latin space. So we have the Latin space, no, it will check that how the data has been distributed. Okay, this encoder maps into the text and single point. So the same thing is happen in the this encoder decoder where we have discussed in the same part. But while generating, this model will not predict, it will generate the new image. So it will understand, it will add some more. While training, encoder decoder need to train with the previous past data. So what are the trained, what are the, for example, while trained, they observe some distribution, means they observe some variation in data. So when they're generating, they apply same variation on that image or text and will generate the new data. So this is the thing is going to happen in encoder decoder concepts. Guys, is it clear? Map the Latin vector Z sample from the Q. We can observe here, right? Code actor is similar to standardized autoencoder, but the output two vectors mu and log sigma squared. So these are the things which will help the model will understand and give the best features to generate. Okay, similar to standard decoder, take the Z as in same as decoder is same as auto variation autoencoders. Okay, autoencoders is nothing but which will help the model to generate new contents. Okay, so they specified this is not a encoder decoder. This is a autoencoders, means which will generate by their own. Okay, learn from Gaussian distribution. Okay, and sampling and non-differentiable operation preventing a back propagation. So sampling they will take care about to main overcome the issues with the values. Okay, so they will use this elbow method objective for use case. Okay, so to overcome the loss. Okay, so they will use two things, regularization loss. So this regularization is nothing but how the decrease loss means will follow some pattern. For example, if the image which they have generated or if the text they which was generated, they are going to have some values, means like they will map between difference between real and fake value. So I think you know the linear regression, how the data, real data is going to be plotted and the fake data is going to plotted, and we'll observe the difference between real and fake, and that they will try to minimize. So in the same way, reconstruction, they will use these loss to minimize the main loss. They'll try to reconstruct the loss. Okay, they'll use this elbow and they'll use scale divergence and the regularization as to reduce the loss between real and fake. Okay, application in where are the industries they use this variational autoencoders, means image generation. Okay, so and repetition learning means nothing but while learning the it going to follow some examples like how semantic variation means nothing but they'll observe the context from the information. See, if the model is learning the word pattern, means like it is observing the words from the data, means like similar words. Okay, but while repetition learning means it is going to not accept the repeating a number of times. So it will, what it will learn, it will learn the meanings of the data. Means for example, how the human being understanding the words. Communication means nothing but the two person will communicate, will say as a communication. Means that we are understanding the meaning of the word. So same as the model will understand the meaning of the word, not the copy of the word. It's not going to copy, it will understand the meaning and it try to overcome them. Data compression. So when there is a use of data compression, they'll use this model. And anomaly detection. What is this anomaly detection means? So in the previously we discussed that one example, the huge new admission will people students entering to the college, they'll segregate means they'll separate the students based on the streams, right? So if there is a person who entered to same with the group, but he is not belongs to BTech, he is not belongs to any masters, okay, he is not belongs to any science department. So here the person is a anomaly, means he is not belongs to any of the class. So then we call it as anomaly. It may be principal, is maybe related to staff, but here we are analyzing only the students for particular streams. But we got in a point that which is not the part of that streams, right? So that we call it as an anomaly. Okay, that which is not follow any patterns or any classification. For example, you are giving a movie ratings. There is a rating which is not rated any 5-star, but we have a review, right? So that it is not going to consider any rating star ratings, right? It's going to consider in a review part. So in that we say it is anomaly. Semi-supervised learning. Variational autoencoders can adapt the leverage of unlabeled data alongside labeled data. It can do both things. You can give unlabeled, label, so then it is can manage semi-supervised learning too. Okay. Limitations, same as it has some different limitation. It will prioritize collapse. So KL divergence term can sometimes dominate the causing of encoder to ignore the X map will all inputs. So these are the thing, elbow gap and simpler area and blur generation. So in some GANs they will use, so in scenarios blur generation. There are some restrictions using this variation. Not only for this, every model is going to have some limitations, means issues. Okay, you need to take care about that limitations. Okay, guys. So next part about transformers, this will discuss in the upcoming session what these transformers will do, what are the things, all these things. Okay. And finally, you have the foundation models also will discuss. Okay. You have the sheet, I think so. This is about variational autoencoders as well as guys. Is the things clear? So what are the topics we discussed today, guys? Please anyone let me know. I forgot, so remember me. What are the topics we discussed today? Okay. Next. What are the topics we discussed in this session? Asking about topics, guys. We discussed three main topics. So we haven't discussed about transformers and LSTM and RN. Yeah. We discussed GANs. Next, we discussed about encoder decoder, and also we discussed variational autoencoder. So these are the topics. So no. So we haven't discussed about transformers till now. So we'll discuss in the upcoming session. Okay. And RN and LSTM are the topics that just I gave an overview. Okay. So is the thing clear? What is mean by GAN? What is mean by GAN? And what is the purpose of GAN? What generally GAN will do? What is mean by GAN, guys? Till now we discussed. What is the full form of GAN? Yeah, generative and the serial network. Okay, what is mean by VIE? Okay, what is the purpose of GAN? So what it will do generally? Guys, is it clear or I need to explain it once again? what generally GAN will do? What is the main purpose of GAN? Okay. Give answer to generate realistic data samples from existing data. Is this correct? Then said that to generate realistic data samples from existing data. Is the GAN will do that? Pratham, that generate data that is similar to real world data. So I will say one thing. GANs will generate new data or unseen data, okay, from noisy data, right? So we are not going to pass any fake data, or else we are not going to train generator. We are just train only the discriminator. So here generator what will do? It will generate the new data based on the noisy data. You need to say noisy means that is not a fake data. We are not passing any fake data. If you say it is a fake data, then it is not going to valid, because the model need to generate fake data, right? So it's going to take from noisy data. Noisy data means the data which is not going to have any valid information. So this GAN will do generally. Good guys, good. Yeah, yeah, you're right. The noisy generate which is similar to real one. That is about guys generator. So variational autoencoder will do these things in a different way. It will do with the text as well as the image also. Okay. So do you have any queries for today's session? See, this is a virtual internship, means that you will get a certification from Google But I didn't know that I will get or not. Strength based, I didn't know. If I get any information, just I will pass. The last date is by June 20, you need to finish. Okay. So who haven't received the credits, just I'll inform to the team again once again. Okay, don't worry. By June 20, you need to finish all the labs, because if you finish as soon as possible, we need to verify that and you need to send that data to the Google. Google will check and just it will issue the your internship certificate. Okay. IBM, you need to finish as soon as possible. First, finish that IBM and go with other things. Do the remaining Google Cloud. Okay? Yeah, you need to do Google all labs, beginner, intermediate, and advanced level labs. If you're done with the labs, just we're going to share a sheet. Just fill the form. Okay, we'll share the sheet and just fill that. We're going to verify and we'll let you know. Yeah, that is the thing. What are the you have in IBM like skill wallet? Just do that. Do what are the shade? No, like intermediate, advanced, and beginner. Whatever you have in a dashboard, just do that. Okay? Do that labs, Google Labs. Okay. So what we are discussing, do that labs. Okay. Beginner, intermediate, and advanced. We'll let you know when the form is going to be shared. We'll let you know and you have to fill it. Okay. Okay, guys, that's it. You can leave if you want. So if you have any queries, just post it in the group. Okay. Feel free. Just learn new things. Guys, this is a remaining class what you have. Just be focused because you are going to learn about generative AI. Okay. Okay, guys, I'm just winding the session. Thank you. Good night. Meet in the next session. You can do whenever you want. You can do. Just finish that labs. Okay. I said no. Just till June 20, you need to finish the all lab activities. Okay. Yeah. Before June 20, you'll get the completion certificate, as well as from Google, you'll get the internship certificate. Okay. No, if you finish all complete 3 courses, then only the Google going to issue the certificate. If you finish 1 or 2 and if you have a certificate, we are not the responsible for that. Okay. Yes, you'll get directly. Okay.